everyone, and welcome back to Teach Astronomy. My name's Victoria, but you guys can call me Vicky. And welcome back to another book stream. Today we're going to be reading Dreams of Other Worlds, Chapter 1. So last week we did the intro, and it was only about 10 pages long. So if you missed that, no worries. I still have it up on the YouTube and in the Twitch archive, but you didn't miss too much. Just kind of was giving us an overview of what we're going to see in the rest of the book. And today we're going to be starting, technically it's apparently labeled as chapter 1, but it's like chapter 1, really. Hello, Lynn Jersey. Hello, Student McLeod. How you guys doing? Jim's in the house. Welcome back. Yeah, so I'm excited. This book, if you weren't here last week, this book is all about the story of unmanned space exploration. So it goes, and it's written by Chris Impey and Holly Henry. And you guys, most of you probably know who Chris is. Holly Henry is a professor at, we looked it up last week. I always forget. I'm going to look that up really quick. Holly Henry is not the singer. That's not what I'm looking for. Holly Henry, author. Where does she teach? No, it's definitely on the back here. Yeah, it totally is on the back of the book. Just kidding. She's a professor of English at California State University, San Bernardino. That's what I was looking for. But yeah, so it's all about unmanned space travel, and each chapter is about a different part of that history and specifically focusing on a different mission. So this chapter is all about Viking and discovering the red planet. So I guess we will just jump right into it. I'm gonna make sure my mic is in a good place. Let me know if I'm too quiet or too loud or anything like that. And yeah, this guy's dense, so we're gonna see how this goes. All right. Discovering the red planet. Sometimes the dream is a nightmare. Mars has always had an ominous mien in myth and culture. Ancient civilizations regarded the planet as a malevolent agent of war and apocalypse. Similar myths emerged around the world. In late Babylonian texts, Mars is identified with Nergal, the fiery god of destruction and war. To the Greeks, Mars was Ares, one of 12 Olympians and the son of Zeus and Hera. His attendants on the battlefield were Deimos and Phobos, terror and fear, and his sister and companion was Eris, the goddess of discord. Ares was an important but an unlikable character. In Roman hands, he was morphed into a virile and noble god, one who facilitated agriculture as well as war. The third month of our year honors him, and the time when winter abated enough that Roman legions could begin their military campaigns. In legend, Mars abandoned his children Romulus and Remus, and the twins went on to found the city of Rome. The mystique of Mars may have been enhanced by its retrograde motion. The fact that every few years it twice reverses its direction of motion among the stars. All exterior planets show this behavior, but the reversal is more dramatic for Mars than for Jupiter and Saturn. It's curious that such a modest speck of reddish light could exert such power. Then it says plate 1. I don't know what that means. Plate 1. Oh! There are pictures. I forgot there are pictures in the middle of the book. I got all the figures that were actually in the chapter and totally forgot there are like full color pictures in the book. So I guess I'll try to show you this because I completely forgot. Maybe I can look it up really quick if it doesn't work. Oh no, you can see that kind of well. The figure here. That's Mars. And it says, more than a century after Percival Lowell mapped Mars, the Hubble Space Telescope turned its best camera onto the red planet, producing this true color image in March 1997, just after the last day of Martian spring in the northern hemisphere. Mars was near its closest approach to Earth, 60 million kilometers away. I could probably find a good picture of Mars really quick if you guys want to see that. Hold on one second. Mars. Hubble. Let's see. I don't think this is exactly... Actually, that might exactly be the picture. Yeah, this one looks pretty close. Let's see it. No. That's not what I wanted. There we go. There. Okay. That's what it looks like. Very pretty. Very nice. And I think that's... if it's not exactly the picture, it's very close. So that's an early picture from Hubble of Mars. And then it looks like Student McLeod put a little link as well. Oh, yes. That's a beautiful picture of Viking, actually. I'm going to save that until we get to the introduction of Viking. That's a great photo. Thank you. Okay. Fast forward nearly 2,000 years, and Mars still exerts a grip on the imagination. It's the night before Halloween, on the eve of World War II. Families across America are settled around the radio to hear The Mercury Theater on the Air, a weekly program directed by the young Orson Welles, and featuring him and a talented ensemble cast. Listeners are enjoying salsa-inflected orchestral music from a hotel in New York City when the announcer breaks in. Quote, "Ladies and gentlemen, we interrupt our program of dance music to bring you a special bulletin from the Intercontinental Radio News." End quote. There's a news report about unusual activity observed on the surface of Mars. Then back to the music. A few minutes later, the announcer breaks in with additional information about Mars. More music. The next interruption has the announcer talking in breathless tones about a meteor that has just landed in New Jersey. Of course they would land in New Jersey. I'm from New Jersey. A little later, on the scene, there's horror in his voice as he describes creatures emerging from the meteor, which is in fact a spaceship. The Martians begin using a heat ray to incinerate bystanders, and as the announcer describes the engulfing flames, his voice is cut off in mid-sentence. Welles deliberately scripts several long seconds of silence, or dead air, to increase the tension and the verisimilitude. In New Jersey and elsewhere around the country, people panic, and many load their belongings into cars to escape the menace. To the modern ear, Welles's broadcast has the tone of cheesy B-grade science fiction. But this was a younger, more innocent world, worried about war and ignorant about the improbability of aliens actually visiting Earth. It was nearly 20 years before America would enter the space age. In fact, the story of invasion from Mars transcends particulars of time and culture. When H.G. Wells's novel, The War of the Worlds, was published in 1898, it was an instant classic. His words retain their evocative power. Quote, "Yet across the gulf of space, intellects vast and cool and unsympathetic regarded our planet with envious eyes, and slowly and surely drew their plans against us. More than a century later, when Steven Spielberg adapted the book for a 2005 movie, the basic plot was unchanged. Fear of alien invasion taps into something deep in the human psyche, as primal as dreams themselves." That's the end of the introduction. My water is not open. Okay. How's everyone doing today? How's everybody's Monday going? I have a long weekend kind of today. It's technically a long weekend, but like this is my only job right now, and I'm not really going to change. But like I'm giving myself off on like the other stuff that I do today. I'm chilling today, you know. How about you guys? How was everybody's weekend? Do anything exciting? It was Valentine's Day here in the United States. I don't know what other countries really celebrate that. We barely celebrate it. I know some people go really all out. Glad to see the plant's grown 0.5 millimeters. I sure hope she's growing a little bit. I don't know. She looks the same every day. From Orson Welles to Spielberg, yes. All right. Evolving views of Mars. Even to the naked eye, Mars clearly varies in brightness over months and years. Mars is roughly 50% farther away from the Sun than the Earth, and its distance from us depends on which side of the Sun each planet is on and the details of their elliptical orbits. At its closest, Mars is only 55 million kilometers away, and at its farthest, it's 400 million kilometers away. This variation corresponds to a factor of 50 in apparent brightness and a factor of 7 in angular size. Only the brightness variation is visible to the naked eye. A telescope is needed to resolve Mars into a pale red disk. Even when it looms closest in the sky, Mars is just 25 arcseconds across, or 70 times smaller than the full moon. Following the invention of the telescope, the view of Mars evolved relatively slowly. Galileo began observing Mars in September 1610. He noticed that it changed in angular size, and he speculated that the planet had phases. The Dutch astronomer Christian Huygens was the first to draw a sketch with surface features, in particular the dark area, or mare, called Syrtis Major. Huygens thought Mars might be inhabited, perhaps by intelligent creatures. In the middle of the 17th century, Giovanni Cassini and Huygens first spotted the pale polar caps of Mars, and in the early 18th century, Cassini's nephew Giacomo Maraldi saw variations in the polar caps that he speculated were due to water freezing and melting during the Martian seasons, although he could not rule out varying clouds. William Herschel used his state-of-the-art telescopes for a period of more than 8 years, beginning in 1777, to bolster the interpretation that the poles were made of frozen water. He had measured the tilt of Mars's spin axis relative to the plane of its orbit, so knew it had similar seasons to the Earth. He had also read Huygens' posthumous book, Cosmotheros, in which the Dutchman speculated about life in the solar system. In an address to the Royal Society in London, Herschel asserted boldly, quote, "These alterations we can hardly ascribe to any other cause than the variable disposition of clouds and vapors floating in the atmosphere of the planet. Mars has a considerable but modest atmosphere, so its inhabitants probably enjoy a situation in many respects similar to our own." End quote. With respect to scientists setting up the expectation of life on Mars so long ago, it's not surprising that the idea had taken deep root by the modern age. Telescope design continued to improve through the 19th century, allowing telescopes to make sharper images and resolve smaller features on Mars. In 1863, the Jesuit astronomer Angelo Secchi saw the Maria appear to change color. He fancifully drew them as green, yellow, blue, and brown at different times. He also saw 2 dark linear features that he referred to as canali, which is Italian for grooves or channels. It was a fateful choice of words, because the literal English translation as canals suggested construction by a technological civilization. That's the end of that section. You said you had a minor panic attack recently, feeling out of the world and in the world at the same time. Existence is weird. So I get that. Hope you're doing okay, though. Random question. But we're talking about Mars. This whole book isn't all about Mars. Don't worry. Don't worry. Mars is pretty cool. But if Mars is the only thing you want to talk about, we're going to talk about other stuff too. What's your guys' favorite planets? I would love to know. I think mine is either Venus or Neptune. I like them both. But what's your guys' favorite planets in the solar system? I'd love to hear why. I'll explain why later if you guys are interested. Why Venus and Neptune are my favorites. Oh, is that Student McLeod? I have that picture actually. Yeah, I have the exact same picture saved. It's gonna come up later. So good on you. Oh, you like Saturn? Nice. Your roommate too. All right. Mars fever. Our vision of distant worlds has improved immensely since Galileo first pointed his slender spyglass at the night sky. Observational astronomy has moved from naked eye observing to the use of large format CCDs. These devices register an image by converting incoming light first into electrons and then into an electrical current, and astronomers typically gather light for several minutes up to an hour before reading out the device and inspecting the image. The CCDs that astronomers use are just larger format versions of the ubiquitous detectors found in digital cameras and cell phones. However, before photography matured, the only detector in astronomy was the unaided eye, and the only way to record an image was to sketch it on paper. Professional and amateur astronomers are familiar with seeing, the rapid fluctuation of images caused by convective motions in the atmosphere. It's the phenomenon that causes stars to twinkle. Viewed through a telescope, star images flicker and dance. But there are moments of stillness when the images become crisp. Observers ever since the time of Galileo have learned to swiftly record the view when the seeing is at its best. In those moments when the light is not quite as scrambled by the atmosphere, features become apparent that are otherwise invisible, and images seem to snap into focus. In 1877, Mars was at its closest approach to the Earth, and Giovanni Schiaparelli was prepared to make the best observations of Mars yet. Already a talented observer, he used his skills as a draughtsman to make rapid sketches of the planet during the moments of sharp viewing, and he built up the stamina needed to concentrate intensely in short bursts through a long winter's night. He made detailed maps, naming features as seas, not because he thought they actually contained water, but by tradition, as had been done with lunar features since the time of Galileo. He saw linear features stretching for hundreds of miles across the surface that were evocative of artificial constructions, although he resisted drawing this conclusion. Meanwhile, a separate debate raged over whether the atmosphere of Mars contained a significant amount of water vapor. Some observers claimed that it did, but it's very difficult to separate the signature of water around a remote planet from the very much stronger signature of water imprinted on light by the Earth's atmosphere. And these observations turned out to be flawed. As an Italian, Schiaparelli used the term canali, which was once again given an erroneous and literal translation in English-speaking media. I'm going to pause there for a second because I have a figure to show you. It's not a figure, it's just a picture, I guess. Here. There it is. So this is the map of Mars that Giovanni Schiaparelli made. So it says it was compiled over the period of 1877 to 1886, so about 9 years, and it showed many linear features that Schiaparelli did not interpret as artificial or as signs of intelligent life. However, Percival Lowell strongly attributed the same features to a dying Martian civilization transporting water from the poles to the equator. So this is what he meant. This is what they meant when they said canals and canali in Italian. So you can see that they almost look like these were just lines on the surface, craters and things like that. But they almost look like canal ways, and as if they had made, big canals to move water and stuff. And then some people, which I'm sure it will discuss in here, some people kind of ran with that, and it got a little confusing. Mars fever began to take hold. The Suez Canal had opened in 1869, so the public was primed to appreciate the engineering achievement implied by canals on Mars. Not every observer could confirm the linear markings, but many of them deferred to Schiaparelli's skill and assumed that their own shortcomings were the obstacle. Amateur astronomer and author William Sheehan has noted the power of this type of thinking, where expectation and projection can shape the sensory experience. Quote, Schiaparelli had taught observers how to see the planet, and eventually it was impossible to see it in any other way. Expectation created illusion. End quote. The scene then shifted to northern Arizona. It was 1894, and Percival Lowell was driving his workers hard. He was racing to build a telescope before a particularly close approach of Mars. The patrician Bostonian had left his gilded life to fuel a personal obsession in the thin air of the northern Arizona desert. The previous Christmas, Lowell had been given a copy of The Planet Mars by Camille Flammarion as a present. Flammarion was a noted French astronomer and popularizer of science, considered by many the early predecessor of Carl Sagan. Flammarion accepted the interpretation that Martian canals represented intelligent life, and in his book wrote, quote, "The actual conditions on Mars are such that it would be wrong to deny that it could be inhabited by human species, whose intelligence and methods of action could be far superior to our own. Neither can we deny that they could have straightened the original rivers and built up a system of canals with the idea of producing a planet-wide circulation system." End quote. Lowell had a prior interest in astronomy, and he correctly judged that the best place to see sharp images was in the high and dry desert air, far from any city lights. The Lowell family motto was, "Seize your opportunity," and Percival took it to heart, dropping his plans of leisurely travel in Asia to venture into the rugged terrain south of the Grand Canyon. For 15 years, Lowell studied Mars diligently and produced a series of drawings of intricate surface markings as he perceived them. To Lowell, the canals were real, and they were manifestly artificial. Around his observations, he wove a story of a dying race, more intelligent than humans, who had built a network of canals to carry water from the poles to the arid equatorial regions. Professional astronomers were skeptical of the observations and their interpretation, and were generally dismissive of the backstory. But Lowell bypassed them with popular books and extensive lecturing. Lowell published his first book on the subject in 1896, titled simply Mars. 2 years later, H.G. Wells incorporated major elements of Lowell's view of Mars into The War of the Worlds, which was very popular and struck a nerve with the public. The War of the Worlds was first published in magazine serial form, in the tradition of the novels of Charles Dickens. As a book, it has never been out of print and has so far spawned 5 movies, a TV series, and numerous imitators. At this point, cultural and scientific views of Mars were closely twined. Lowell's 1906 book, Mars and Its Canals, met with a strong rebuttal from Alfred Russel Wallace, co-discoverer of the theory of natural selection, who argued that Mars was far too cold to host liquid water. He considered that the polar caps were made of frozen carbon dioxide, not water ice, and he concluded that Mars was uninhabited, and uninhabitable. Wallace's critique made no difference in the cultural arena. 10 years later, Edgar Rice Burroughs published A Princess of Mars, set on a version of the red planet alive with exotic animals, fierce warriors, and princesses in near-human form. He wrote another 10 Mars stories over the following 30 years, inspiring Arthur C. Clarke and Ray Bradbury, and launching a grand tradition of Mars science fiction. Mars fever was resistant to the medicine of improved astronomical observations. Lowell stubbornly defended his position until the end of his life, saying in 1916, quote, "Since the theory of intelligent life on the planet was first enunciated 21 years ago, every new fact discovered has been found to be accordant with it. Not a single thing has been detected which it does not explain. This is really a remarkable record for a theory. It has, of course, met the fate of any new idea, which has both the fortune and the misfortune to be ahead of the times and has risen above it. New facts have but buttressed the old, while every year adds to the number of those who have seen the evidence for themselves." End quote. By 1938, telescopic remote sensing had demonstrated beyond any reasonable doubt that Mars was a dry, barren, lifeless desert. But that didn't dim the twinkle in Orson Welles' eye as he reeled the public in with his artful hoax. The fever cooled dramatically in 1965 with Mariner 4. Spurred into existence by a series of firsts for the Soviets in space, NASA was a young government agency with ambitious plans. By the mid-1960s, the hardware development for the Apollo program was in full swing. But NASA also wanted to gain the initiative in interplanetary probes. The Mariner series of space probes was designed to investigate the inner solar system. Space exploration was definitely not for the faint of heart. In the 1960s, roughly half of NASA's probes failed. Mariners 1 and 2 were intended for Venus. Mariner 1 veered off course and had to be destroyed just after launch, while Mariner 2 made it to Venus and transmitted useful data as it flew by. Venus was known to have thick, opaque clouds, so there was no camera on board. Mariners 3 and 4 were intended for Mars. Mariner 3 mysteriously lost power 8 hours after launch, so all eyes turned to Mariner 4. After 7 months and 220 million kilometers of travel and one mid-course correction, it swooped within 10,000 kilometers of the planet's surface. The spacecraft sent back 21 black and white images, the first pictures ever taken of a world beyond the moon by a space probe. The images were small and grainy, with 8 times worse resolution and 60 times fewer pixels than a typical cell phone camera. And this was written like 7 years ago, so keep that in mind too. They showed a barren and cratered surface. Other instruments indicated a sparse atmosphere, daytime high temperatures of negative 100 Celsius, and no magnetic field that would be needed to protect the planet from harmful cosmic rays. Mars, so deeply rooted in the popular consciousness as a living world, seemed to be moon-like and lifeless. That's the end of that section. Gotta take my water breaks when I can. Your favorite non-Earth planet's Venus because it's actually one of the 3 great elven jewels. Ooh. Nice, that's cool. A Tolkien reference, yeah. I haven't read any of the Tolkien books, actually, and I should. I'm a huge fan of fantasy and science fiction stuff, and I really should read them. I've heard they're excellent, though. All right. This chapter is just massive. This whole book is massive. The text is so small. I hope you guys are enjoying it so far, though, because the next section is the Vikings reach Mars. So now we're finally talking about Vikings. On July 20th, 1976, a small spacecraft emerged from a cloudless, apricot-colored Martian sky and fell toward the western Chrysoplanatia, the Golden Plain. Its heat shield glowed as it buffeted through the tenuous atmosphere. About 4 miles up, the parachutes deployed. The heat shield was jettisoned, and 3 landing legs unfolded like a claw. At 1 mile up, the retro rockets fired, and less than a minute later, the Viking 1 lander decelerated to 6 miles per hour, reaching the surface with a slight jolt. It was a landmark of technological prowess, the first time humans had ever soft-landed an emissary on another planet. The twin Viking missions were the most complex planetary probes ever designed. Their total price tag was around $1 billion, equivalent to $4 billion today after adjusting for inflation. American US dollars. That can be compared to the $80 million cost of Mariner 4. Mission planners were well aware of the challenges. The Soviets had previously failed 4 times to soft land on Mars. Each Viking consisted of an orbiter designed to image the planet and a lander equipped to carry out detailed experiments on the surface. For the most part, the hardware worked flawlessly, but there were tense moments for the engineers and scientists on the team. After 10 months and 100 million miles of traveling, the Vikings reached Mars 2 weeks apart. The first landing had been planned for July 4th, 1976, the nation's bicentennial, and the landing sites were selected after years of deliberation. But as their twin orbiters started mapping the planet with 10 times sharper images than had ever been taken before, mission planners were shocked to see that the planned Viking 1 landing site was not the benign plain they'd expected, but the rock-strewn bottom of what appeared to be a riverbed. The landing site was abandoned. Gentry Lee, the director of science analysis and mission planning for Viking, vividly recalled the turmoil of the new images caused. Quote, "For almost 3 years, the Viking flight team operated at an unbelievable pace and intensity. Many of the key members of the team, including not just the engineers, but also Jim Martin and Tom Young, and many of the world's foremost planetary scientists, worked 14 or more hours a day for the entire period. Landing site staff meetings to synthesize the results and look at all the logical options were held every day. Carl Sagan, Mike Carr, Hal Masurski Carl Sagan, Mike Carr, and Hal Masurski, and other famous Viking scientists argued eloquently about the safety of each of the candidate landing sites. Finally, the exhausted operations team managed to reach a consensus. End quote. A new site at Christ Planitia was selected. Once the lander separated from the orbiter, it would not be possible to redirect the lander with any additional commands. The die was cast. Few team members slept much that night. Media coverage and public interest were intense. Viking 1 and 2 marked the first close-up glimpse of the red rocky soil of Mars. Quote, despite the early hour, the von Karman Auditorium at NASA's Jet Propulsion Laboratory was packed. In addition to 400 journalists from around the world, there were 1,800 invited guests watching a closed-circuit television view showing the control room, with Albert Hibbs, one of the mission planners, providing the commentary. End quote. For 19 agonizing minutes, everyone waited. That was how long it took for telemetry to reach the Earth saying the lander was safe. Its first picture was of its own foot, to see how far it had sunk into the Martian soil. When, on its second day on Mars, Viking 1 sent back the first color panoramic views of the Martian terrain, scientists and public audiences alike recognized a kind of reddish, iron-rich soil familiar to them from the deserts of the American Southwest. In fact, among the first panoramic views released to the press was a view of the Martian landscape under blue skies. The JPL scientists quickly realized the sky should be salmon-colored. As Paolo Ulivi and David Harlan note, quote, initially, the image processing laboratory combined the red, green, and blue frames to produce the dark blue-black sky that the thin atmosphere had been expected to yield. But after the images had been recalibrated, the sky was found to be pinkish-orange. The missions galvanized global fascination with the stark Martian landscape, and they continued to provide a compelling story of discovery and of the sheer difficulty of trying to do science so far from a conventional laboratory. The feelings were best described by NASA's Gentry Lee. Quote, the Viking team didn't know the Martian atmosphere very well. We had almost no idea about the terrain or the rocks, and yet we had the temerity to try a soft land on the surface. We were both terrified and exhilarated. All of us exploded with joy and pride when we saw that we had indeed landed safely. End quote. That's that section. And also there is a plate here that it referenced, so let me figure out what that is. Oh, it's Mars as seen by the Viking 2 lander. So let me pull up a picture of that. Hope everyone's doing well today. Feel like normally I have a bunch of like stuff to chit chat about, and I don't really have a lot today. It's kind of a lazy day, you know? No, don't save the picture. Open the picture. There it is. I think, hopefully this is the right picture. But there she is. That is our friendly neighborhood red planet. As seen from, I think that's the picture. That might not be the exact picture that's in the book, but it is Mars. That's seen by the Viking 2 lander. And this caption essentially just says that this was the nail in the coffin for Percival Lowell's and many others' ideas that this planet could be habitable, because it is quite barren, and it's very reminiscent of, like, if you've been to like Sedona in Arizona, and like I think Utah has some like red rock desert too. I don't know. I haven't actually been to much of Utah. Or maybe lower Colorado, I'm not sure, but that like red rock desert in the United States, it's got a very similar feel to that. You don't have a favorite planet? You've been fascinated by black holes since high school? Oh, yeah, we actually just, our last book that we read was about black holes, but we're always talking about black hole stuff with Professor Impey during his Q&A sessions that we do every week. So if you want to hear about some of that stuff too, you should tune in for those. Black holes are wild. They're really cool. There are 2 ways to read Tolkien's major works. One in chronological order. Okay. Or in order by reading difficulty. Hobbit was written for children. Lord of the Rings for teens. Gotcha. I've actually never heard of Silmarillion. Is that how you say it? I've never heard of that because I saw like a Hobbit movie. This is so off topic, so apologies. But I saw a Hobbit movie from like the 70s. It was like this animated movie that everyone forgets about. Yeah, I saw that one, and then I saw a few of the Lord of the Rings. I think I saw 1 or 2, but I haven't read any of them, but I will. Notice the sky's color caused by the chemical composition. Yeah, it's crazy. I can go back to it for a second. I would call, that's not the right one. There we go. I would call that color like they say it's like a pinkish salmon in here, I think. But I would say it's more of like what do you guys think? Like a tannish pink. I'd say it's like tan tinged with some pink, really. That's like pretty much it. Does Professor Impey favor the enormous expense of human planetary exploration? I don't know if I quite understand your question, Oxwoman. Oh gosh, I keep turning on the wrong things. There we go. Does Professor Impey favor the enormous expense of human planetary exploration, or that done by robotics? Well, so I think you're just talking about which one does he which one does he find more value in, maybe? I think both, because this book he specifically wanted to focus on unmanned space exploration, but he actually has another book all about manned space exploration. And I think he, along with a lot of other astronomers and people who work in and around the field, both methods are very valuable for different reasons. Because there's a lot of things that robots can't do that humans can. And there are a lot of things that we can't learn unless we actually go up to space ourselves. But then there's a lot of things that are too dangerous or just not feasible or not reasonable for a human to do. So things like we could never obviously just put a human on a ship and send them out to Pluto for however long New Horizons took. 7 or 8 years. It was a long time. And then just let them keep going. We couldn't do that with the Voyager missions that are now, I think they're both outside the solar system, outside like the line of the solar system. So for things like that, like unmanned is the only way to go. So I think there's a lot of value in both of them. And I think he would agree. Good chapter to fully recommend The Martian Chronicles. Oh, yeah. Yeah, The Martian Chronicles. That's by, oh my gosh, who is that by? Hold on. Ray Bradbury. That's what it is. Yeah, I haven't read it. I've heard it's excellent. Ray Bradbury writes a lot of good stuff. There's also the Red Mars series. There's a bunch of really great books about Mars and societies on Mars, either aliens or future human societies and stuff, and colonizing Mars. And a lot of it's fueled by all of the speculation that it was habitable or habited in the early days of looking at Mars. Oh, so the Silmarillion is like Silmarillion, is that how you say it? Is like a history of the whole world sort of thing. I like that. That sounds cool. The real story occurs in the cell. Oh, okay. Nice. That sounds fun. All right. Back to Viking. What we learned. What have we learned today? No. What we learned. Viking 1 was launched from Cape Canaveral on August 20th, 1975. Its twin was launched on September 9th, 1975, and Viking 2 reached Mars on August 7th, 1976, a few weeks after the first triumphant landing. The second lander reached a site several thousand miles away at Utopia Planitia on September 3rd, 1976, after suffering its own small mishaps. The downward-looking radar was probably confused by a rock or reflective surface, so the thrusters fired too long, cracking the soil and throwing up dust. It stopped with one leg resting on a rock, tilting the lander by 8 degrees. Otherwise, it was unharmed. Okay, so that picture I showed you guys might have been from Viking 2, because it was tilted a little bit. So it's still one of the Viking pictures, but it might have been from Viking 2, because that may be why it was tilted a little. Anyway, the hardware was designed to last for... I said otherwise it was unharmed, right? Okay. Sorry. It's like, I want to make sure I'm in the right spot. The hardware was designed to last for 90 days, but proved to be very durable. Viking 1's orbiter lasted nearly 2 years, and Viking 2's orbiter lasted just over 4. Meanwhile, on the surface, the Viking 2 lander ceased operation when its battery failed after 3.5 years, while the indomitable Viking 1 lander was going strong after more than 6 years, when simple human error during a software update made the antenna retract and communication with the Earth was lost. Oh, that's so upsetting. I didn't know that's how it went. Oh. Public attention focused on the landers, with their life detection experiments and "you are there" images. But the orbiters were also very important in shaping a modern view of Mars. The orbiters carried the landers The orbiters carried the landers to Mars, scouted for landing sites, and relayed lander data back to Earth. Each equipped with optical and infrared imagers, they mapped 97% of the surface and sent back over 46,000 images. They could see features 150 to 300 meters across anywhere on the planet, and in selected areas they could resolve features the size of a small house. Whereas Mariner had only seen old, cratered terrain, the Vikings saw rich and varied topography and geology. There were immense volcanoes, corrugated lava plains, deep canyons, and wind-carved features. The planet was divided into northern low plains and southern highlands that were pockmarked with craters. Mars had extensive elevated regions of volcanism, although no areas of fresh lava. There was weather, dust storms, pressure variations, and gas circulating between the poles. As NASA's Thomas Much said of the Viking orbiter images, quote, "They show Mars as an extremely diverse planet. It is difficult to avoid the conclusion that, though Viking contributed immeasurably to breaking the code of the Mars Enigma, we do not yet confidently understand its dramatic and turbulent past." Most excitingly, Viking provided indirect but compelling evidence for water. Not currently. The air is so cold and thin that a cup of water placed on the surface would evaporate away in seconds. But the orbiter sent back images of rock formations all over Mars that could only have been produced by the action of large amounts of liquid water in the past. Huge river valleys were seen, in places where it looked like rivers had once fanned out into a spider's web of channels that ended in ancient shallow seas. The flanks of volcanoes had grooves that on Earth indicate water erosion. Many craters had shapes that were consistent with the impactor landing in mud. Other regions of chaotic terrain looked as if they had collapsed when other underground volcanism melted ice, which then flowed away as water. The water flows implied by these features were equal to the greatest rivers on Earth. And there's a figure for me to show you. Let me grab that. There it is. So this is... This says 4 decades after Mariner 9 saw the first signs that Mars had been wet in the ancient past, the evidence for geological formations that can only result from the action of water has grown much stronger. And these images from the Mars Global Surveyor mission, so this is not from Viking, this is from a later mission, features are suggestive of episodic eruptions of subsurface water, altering the landscape before the water evaporates and boils into space. So, you can see here, it says apron covering dunes, apron on polygons, and fresh dust-free surfaces. So there's clearly a difference in surfaces that you can see where like you can't see my cursor. There we go. Where these two clearly have been, eroded down, and it seems like they were eroded down by flowing water at some point, whereas this fresh dust-free surface is much more rocky and not smooth the way that water would smooth something like this. Yeah. I'm supposed to know every word of every book off the top of my head. I know. I have failed. You'd say maybe a light butterscotch color. Yeah, I like that. A butterscotch color. Silmarillion. Okay. Right up to Bilbo Baggins. Wow. That's cool. I like that. Tolkien was just like, I'm going to write an entire history for a world that I invented. And it's going to be great. I like that. Okay. Searching for life. The grip that Mars holds on the popular imagination is grounded in the question of whether Mars ever was, or is, alive. The Viking landers were explicitly designed to search for evidence of life in the Martian regolith, or perhaps in the planet's geological past. The short section of the mission science summary on life detection is worth quoting in full because of the surprising ambiguity of the wording. Quote, 3 experiments were conducted to test directly for life on Mars. The tests revealed a surprisingly chemically active surface, very likely oxidizing. All experiments yielded results, but these are subject to wide interpretation. No conclusions were reached concerning the existence of life on Mars. End quote. That is so vague. The Viking landers packed a substantial scientific punch in their 200-pound payloads. Power came from a plutonium-238 radioisotope thermal generator, eking out 30 watts of continuous power. Using late 1970s technology, Viking's data capabilities were even more feeble. The data recorder on each lander could only store 8 is that megabytes? I think so. It's just a capital M bytes. I'm pretty sure that's megabytes. It could only store 8 megabytes at a time. Thousands of times less than the average memory stick. That's crazy. I mean, now you can buy I've got a hard drive right here. This is 2 terabytes. And it could only hold 8 megabytes. The whole Viking lander. Crazy. The landers had cameras that could take 360-degree panoramic images. They had seismometers and instruments to test magnetic fields. They had meteorology booms that measured temperature, pressure, and wind speed and direction. Most importantly, they had robotic arms that could scoop up soil samples and deposit them into temperature-controlled and sealed containers on each spacecraft. And there is another figure. Just a quick one, showing you guys. And this one's pretty blurry, I think, mainly because the image quality on Viking wasn't great, as we discussed. But this is a mosaic of a couple of those 360-degree panoramic images. This isn't a full one, but it's a mosaic of some of the images from where they landed. So you can see the arm there, right there. This is the robotic arm that's scooping out some of the Martian soil. So yeah, pretty cool. Butterscotch, that's actually a wonderful new word to learn. Yeah, butterscotch is a lovely the translation to Spanish is caramelo de azúcar con mantequilla. Oh my god. Sometimes when you're translating stuff into a different language, it's like, oh, this one little word is like actually 7 words in this other language. That's fun. Thank you so much for the subscription, Lynn Jersey. Oh, that's your 3rd month. Thank you so much. You didn't have to do that. Oh, thank you. The image on the right showed the little trench caused by the scooping arm. Yeah, you can see it there. Right there. That's where he scooped out some and took it back. Very cool. Yeah, for Lynn. Jim's so excited. All right. Let's continue. The biological package contained 4 instruments. A gas sorry. Sometimes the words, when they're broken up, they have the half the word dash. I just really stumble over them because I'm like, what's going to be the other half of the word? Not what I expected. Anyway. A gas chromatograph and mass spectrometer heated soil samples and measured the molecular weight of each component of the vapor released, down to a concentration of a few parts per billion. The instrument found no significant levels of organic or carbon-based molecules. Mars soil had even less carbon than the lifeless soils tested on the moon by the Apollo missions. This seemed to be prima facie? I've never heard that before. I'm assuming that means clear. This seemed to be prima facie evidence against life. The gas exchange instrument added nutrients, and then water, to a soil sample, and then looked for changes in the concentration of gases such as oxygen and methane in the sealed chamber. The hypothesis was that a living organism would process one of the gases. The result was negative. The pyrolytic release experiment created an atmosphere in the chamber using radioactive carbon, in the hope that a photosynthetic organism would incorporate the carbon the way plants do on Earth. After several days of incubation under an artificial sun, in this case a xenon arc lamp, the sample was baked at a high temperature to see if any of the radioactive carbon had been converted into biomass. The results were also negative. The only wild card was the labeled release experiment. A sample of soil had nutrients dissolved in water added to it, and the nutrients were tagged with retroactive carbon, which was once again used as a tracer. To the surprise of the instrument team, radioactive carbon dioxide was detected in the air above the samples, suggesting that microbes had metabolized one or more of the ingredients. The same result was seen in both Viking landers. However, when the experiment was repeated a week later, the air was free of radioactive carbon. The data were declared inconclusive. Overall, the results were disheartening for those who had hoped that Mars might be a living world. Terrestrial life is based on complex molecules with a carbon backbone, organic ingredients like carbohydrates, proteins, nucleic acids, and lipids. While organic does not mean biological, all life on Earth is carbon-based and so is made of organic ingredients. The Viking experiments detected virtually no organic compounds in the Martian regolith. This was somewhat surprising, since they are fairly common on small solar system bodies, like comets, asteroids, and meteorites. With no organic material, the biological experiments would have been doomed to failure, since their aim was to detect a metabolism that can incorporate carbon from the atmosphere, as microbes on Earth do. The lander could only gather samples from the top few centimeters of the regolith, and that layer is blasted with ultraviolet radiation and cosmic rays from space, since Mars has no protective layer of ozone. The surface is strongly oxidizing, as the rusty red color of iron oxide indicates. So the conventional interpretation is that activity seen in the experiments was caused by chemical reactions involving oxidizing molecules in the soil, with no biological explanation required. That's the end of that section. And I think, if you guys don't mind, we've been going for just about an hour now. I am going to try something new, because we're going to have another hour. Don't worry. We're going to finish this chapter. But I just wanted to run to the bathroom really quick, and I made a little thing that I think will work as an ad break. I'm going to try to do an ad break. We're going to try it. I hope that's okay with everyone. It's only going to be 60 seconds. And I'm going to run to the bathroom really quick, and hopefully this doesn't break the stream. So I'll be right back. I'm going to put on a little ad break. You can listen to music. If you're a subscriber, you'll just get to listen to music. And I'll be right back. Okay. Did that work? Let me know if that worked. And I guess let me know how bad the ads were. I just figured it was a way for me to get a quick bathroom break in the middle of these, because 2 hours is quite a long time. And also, if you guys, as long as you guys don't mind watching a few, just a minute of ads, it does give us a few extra cents, you know? So helps us out a little bit. No ads, just techno music. Nice. All right. Maybe it didn't let me do the ads. I don't know. I'm glad you guys like the music. Yeah, I was having fun with it. Because we have the music for those, and also the pre and post stream, because we have a post stream now. So if you guys are like chit-chatting with stuff or ask some questions and we gotta peace out, you get like 5 minutes left to throw your last few things in there, which is nice. Also, really quick, because I know not everyone is going to be able to stay for the whole thing, but it looks like we have a good amount of viewers right now. I just wanted to let you guys know that we are actually, so that thing that we have been talking about forever of having Professor Chris Impey do an extra Q&A stream where he answers questions not about like astronomy and astrophysics, but just about his life and his life experiences and his career and all the cool stuff that he's done, because he's done so many cool things. We're finally going to do that, and it's going to be a special subscriber only chat stream, so everyone can watch it. Don't worry, whether you're a subscriber or not, you can come and hang out, but only subscribers will be able to chat in the side chat and ask questions. So just as a little bonus, and we're going to do it probably like once a month, once every like month and a half or so, depending on what Chris's availability is. But that's a fun little thing. So if you guys want to ask your questions for Chris, you guys can subscribe. It's like $5, and half of it goes to us, which is really cool. Also, if you have Amazon Prime, you get a free subscription. So that is also a thing. And if you need help figuring out how to do that, I, a while ago, made a little video that I can link. If anyone wants it, just let me know, that I can link you to explain how to hook those two up, because it's pretty easy and it's totally free and it helps out our channel. But yeah, so that's an exciting thing. It's going to be happening on March 2nd at, I believe 11 a.m. I can check that time really quick, but it's going to be really fun. We're going to, I'm going to have a bunch of questions for him. If you guys tuned into the author chat, it's going to be more of that casual sort of thing, that we did then, but all about, you know, his cool life experiences, because he's got so many, to talk about. I'm going to look this up later, actually, but, yeah, March 2nd. So mark your calendars. That'll be fun. All right, let's get back to the book. Here we go. Could Viking have missed life? I think that, sorry, the first words of this or this section is a name, and I think it's Gil, G-I-L, but it could be Jill. I think it's Gil. Jill would be a J. We're going to go with Gil. Okay. Gil Levin has never wavered. The principal investigator of Viking's labeled release experiment is now approaching 90, but he's very active and stays current with research on Mars. Levin had an unusual career path, starting as a sanitation engineer before joining NASA. In addition to authoring 120 scientific papers, he owns 50 patents for items ranging from artificial sweeteners to therapeutic drugs. Levin insists that at 2 locations on Mars, and in 7 out of 9 tests, his experiment detected biological activity. No purely chemical reactions have been identified that would fully reproduce the labeled release results, which explains the cautious and equivocal wording of the science mission summary. Levin is in the minority, but he's not alone in believing the Viking results bear revisiting. Rafael Navarro Gonzalez and his team went to the highest and driest parts of the world, places like the Atacama Desert and Antarctic dry valleys, and duplicated the test that Viking did more than 35 years ago. In northern Chile, they found arid soils with levels of organic material that would have been undetectable by the Viking instruments. Yet there were bacteria in the soil. In other words, Viking was not sensitive enough to detect either organics or life in terrestrial locations that are the closest analogs to Mars. The team speculated that the organic material on Mars might have been too stable to turn into a gas, even at the blistering temperature of 500 degrees Celsius, or 932 degrees Fahrenheit, reached inside the oven of the Viking experiment. They also noted that iron in the soil might oxidize the organic material and prevent its detection by the mass spectrometer. This would account for the carbon dioxide that was detected in the experiments. Mars is an alien chemical and physical environment, so it makes sense to think outside the box when considering how biology might operate there. If we only look for life as we know it, that's all we'll be able to detect, and we may miss life with a different biochemical basis. Dirk Schultz-Makuch and Joop Houtcooper have speculated that Mars might be home to oh my gosh. I want to keep saying like microbiomes. I don't think that's a thing. Mars might be home to microbes that use water and hydrogen peroxide as the basis for their metabolism. Hydrogen peroxide is a toxic household disinfectant and seems implausible as a basis for life. But the researchers note that it's more life-friendly under the extreme conditions typical of Mars. It attracts water, and when mixed with water freezes at negative 57 degrees Celsius. Yet it doesn't form cell-destroying ice crystals at even lower temperatures. Hydrogen peroxide is tolerated by many terrestrial microbes, and is the basis of metabolism for Acetobacter peroxidans. Sure. It's used as a defensive spray by the bombardier beetle and even performs useful functions in the cells of some mammals. As Schultz-Makuch pointed out in 2007, quote, "We can be absolutely wrong, and there might not be organisms like that at all. But it's a consistent explanation that would explain the Viking results. If the hypothesis is true, it would mean we killed the Martian microbes during our first extraterrestrial contact by drowning due to ignorance." End quote. Another speculation was spurred by the discovery of perchlorate in a Martian polar region by the Phoenix lander in 2008. Phoenix carried out a wet chemical analysis of Martian soil, finding it to be alkaline and low in the type of salts found on Earth. But it had enough perchlorate to act as antifreeze and allow the soil to hold liquids for short periods during the summer. Perchlorate is strongly oxidizing, and so generally considered to be toxic for life. But some microbes metabolize it. In 2010, the Viking results were reinterpreted in the light of the Phoenix discovery, giving support to Gil Levin's lonely position. When perchlorate was added to Atacama Desert soils and analyzed in the manner of the Viking samples, it released chlorine compounds. When these were seen in the Viking experiments back in 1970, they were presumed to be cleaning fluid contaminants from Earth. But if perchlorate is present in the mid-latitude Martian soil, it would explain the data. Since perchlorate becomes a strong oxidant when heated, it would have destroyed any organics and so explain why Viking didn't detect any. It's remarkable that the Viking legacy continues to provide so many surprises and unanswered questions. A leitmotif in the reinterpretation of the Viking biological experiments is the amazing range of life on Earth. There are microbes that can tolerate or thrive in conditions that would be fatal to plants and animals. Collectively, forms of life found in physically extreme conditions are called extremophiles. The envelope of The envelope of habitability is much larger than we thought in the 1970s. There are microbes that can live below the freezing point of water and with toxic and alkaline conditions as seen on Mars. Even high doses of ultraviolet radiation are not an impediment to life, since microbes can survive conditions in the upper stratosphere that match the radiation environment of Mars. In science, proof is the gold standard, but it's a very high bar to clear, usually requiring copious amounts of evidence. While Viking didn't find life on Mars, it was unable to prove the converse hypothesis, that biology is absent. It's premature to declare Mars dead. Surprisingly, this harsh planet inspired a new way of thinking about life on Earth. That's the end of that section. Prima facie is a Latin phrase used in law based on first impression accepted as correct until proved otherwise. Nice. Thank you for that, cat sleuth. A word sleuth, I might say. Hello. I do not know how to pronounce. Luxter? We'll go with that. Hello and welcome. Hydrogen peroxide is H2O2. Yeah, it's just one oxygen atom away from water. It's crazy, you know? One atom changes it from something that we need to live to something that can super easily kill us. But yeah. All right. Mars and the birth of Gaia. A substantial legacy of Viking is that scientists have gained a better sense of the finely tuned ballet of biogeochemical cycles. Oh my gosh. Biogeochemical cycles that sustain Earth's vibrant biosphere. The Viking missions unexpectedly became integral to the late 20th century. Oh my gosh. Gotta start this over. Okay. A substantial legacy of Viking is that the scientists have gained a better sense of the finely tuned ballet of biogeochemical cycles that sustain Earth's vibrant biosphere. The Viking missions unexpectedly became integral to the late 20th century view of the Earth's biosphere as a self-sustaining system produced by biota interacting with the planet's geochemistry. Brian Skinner and Barbara Merck assert that future historians will consider discovery of the complex interactions between Earth's biota and geologic, hydrologic, and atmospheric cycles among the most significant scientific contributions of the 20th century. This sea change in thinking about our planet began to emerge in the 1960s and was sparked by British scientist James Lovelock's Gaia hypothesis. That idea later evolved into Gaia theory, and the academic discipline referred to as Earth System Science. In the early 1960s, Lovelock was working for NASA's Jet Propulsion Laboratory with other planetary scientists to develop the experimental means for determining whether microbial life might exist on Mars. NASA's plan for a mission to robotically explore Mars in search of life was initially titled Voyager, not to be confused with the interplanetary mission launched in 1977. That plan was substantially scrubbed and reconfigured into what became the Viking mission. In 1965, while helping to develop life detection experiments for the Mars landers, Lovelock came to the sudden realization that Earth's atmosphere must be a natural extension and a byproduct of Earth biota. This became the basis for the Gaia hypothesis and a paper Lovelock published in the prestigious journal Nature that year. In his first book, Gaia, A New Look at Life on Earth, from 1979, Lovelock, then 60 years old, explained that as he mulled over ways one could detect organisms in the Martian soil, he turned to our own planet and began to imaginatively, quote, look at the Earth's atmosphere from the top down, from space, end quote. In the opening sentence, Lovelock observed, quote, as I write, 2 Viking spacecraft are circling our fellow planet Mars, awaiting landfall instructions from the Earth. Their mission is to search for life, or evidence of life, now or long ago. This book also is about a search for life. End quote. The organisms on Lovelock's mind, however, were those on Earth. Lovelock thought it might be possible to answer the question of whether Mars harbored microbes by simply examining the composition of the atmosphere. If a planet supported life, Lovelock posited, its atmosphere would be shaped in part by biota, quote, bound to use the fluid media, oceans, atmosphere, or both, as conveyor belts for raw materials and waste products. The atmosphere of a life-bearing planet would thus become recognizably different from a dead planet, end quote. A mix of reactive atmospheric gases like oxygen and methane, Lovelock surmised, would be a biosignature of life as on Earth. Moreover, in 1965, researchers at the Pic de Midi Observatory in France reported that the atmospheres of Venus and Mars were largely made of carbon dioxide. Lovelock knew that Earth's atmosphere, by comparison, contained reactive gases that dissipate if not continuously replenished by Earth's biota. The Pic de Midi observations seemed a sure confirmation to Lovelock, who was then collaborating and publishing with NASA colleague Deanne Hitchcock on analyses of infrared surveys of the Martian atmosphere. Methane in our atmosphere, quote, has been fairly constant as ice core analyses prove for the past million years, as has oxygen, end quote, notes Lovelock, who highlights the fact that, quote, for such constancy to happen by chance is infinitely improbable, end quote, and therefore must be sustained by life. While Lovelock set the wheels in motion for a systems approach to understanding the biosphere, it was his collaboration with microbiologist Lynn Margulis that formalized the Gaia hypothesis. Margulis was just then developing her theory of symbiogenesis, which posits that cell structure, and ultimately organisms, evolved from symbiotic relationships between progenitor cells or organisms. She is celebrated for her research in early cell evolution and was first to identify bacteria as the antecedent of chloroplasts and mitochondria in eukaryotic cells. Margulis also was interested in how bacteria and other microorganisms might impact their environment. As it happened, Lovelock shared an office at JPL with planetary scientist Carl Sagan. Lovelock biographers John and Mary Grimman comment, quote, Margulis had independently become intrigued by the oddity of the Earth's oxygen-rich atmosphere and asked her former husband, Carl Sagan, whom she ought to discuss the puzzle with. Sagan knew just the man and put her in touch with Lovelock. End quote. Upon Sagan's recommendation, Lovelock and Margulis began exploring the question of how the highly reactive gas oxygen in our atmosphere has been sustained at a consistent level over billions of years. That's the end of that section. Oh, the name of the book. It's called Dreams of Other Worlds. Is at Universal Cross Servers. I think so. Yeah, it's called Dreams of Other Worlds, and it's by Professor. Well, I always say professor because we always call him professor, but Chris Impey and Holly Henry, and it's from 2013, I believe. This edition, at least. They wrote the first one earlier than that. That was cool. While I was reading that, I kept thinking about, because, with the whole thing of looking at the atmospheres for signs of life, reminded me of the recent, so far not confirmed, but, still holding out hope for the Venus, what was it? Was it, what did they find in the Venus atmosphere? Phosphine? I think so. I think it was phosphine. Which is, if true, the phosphine is a good sign that there is something going on there, some possible life, because phosphine is another one of those elements that the scientists were looking for that, don't stay in an atmosphere for very long and could indicate life. It's very exciting. Also, I almost forgot to show you guys a picture of Mr. Carl Sagan. So this is a picture of him with the Voyager craft, Voyager, the Viking lander, in Death Valley in California. So it just mentions that he was a pivotal figure in the mission planning, leading the argument to include a camera in the design. His research pointed to the intimate connection between the composition of a planetary atmosphere and its habitability. And there he is. So that's also a little, little indication of size there. Spell check keeps changing your words. That's so frustrating. What is this Nature article? Oh, yeah, there it is. So, yeah, if you guys are interested, Astro Kiriani just put in the chat a link to the article about the phosphine discovery on Venus. It looks pretty dense. It looks like it's from Nature, so it's probably like a full-on scientific paper. But if you guys are interested, go for it. He was so honored the night he got to shake your right hand following a lecture here in Charlotte, North Carolina. That's awesome. That's so cool. I'm sure he was. Yeah, Carl Sagan's really cool. Hell of a legacy. All right. Gaia theory and Earth system science. Together, Lovelock and Margulis theorized that Earth's habitability was not simply a function of its orbital position relative to the Sun, but was in large part due to biota metabolizing and cycling atmospheric gases and rock minerals. As Margulis explained, quote, "The metabolism, growth, and multiple interactions of the biota modulate the temperature, acidity, alkalinity, and, with respect to chemically reactive gases, atmospheric composition at the Earth's surface." End quote. While Lovelock considered the impact of all forms of life in using and maintaining Earth's biosphere, Margulis's contribution to Gaia in the early 1970s highlighted the shaping effects of microorganisms relative to atmospheric chemistry, rock weathering, and carbon deposition via phytoplankton on the seafloor. Lovelock wrote, quote, "Lynn brought her deep understanding of microbiology to what until then had been mainly a system science theory that saw a self-regulating Earth through the eyes of a physical chemist. By stressing the importance of the Earth's bacterial ecosystem and its being the fundamental infrastructure of the planet, Lynn put flesh on the skeleton of Gaia." End quote. Shout out to Lynn Jersey for sharing a name with this scientist. However, in the early 1970s, when Lovelock and Margulis floated their ideas regarding Gaia, Earth sciences... Oh, Jesus. Sorry, sometimes I just don't get that emphasis correct. And I just want to restart the sentence. However, in the early 1970s, when Lovelock and Margulis floated their ideas regarding Gaia, Earth sciences were largely studied in isolation. Quote, "Oxygen, for example, was thought to come solely from the breakdown of water vapor and the escape of hydrogen into space, leaving an excess of oxygen behind," explains Lovelock. Quote, "Life merely borrowed gases from the atmosphere and returned them unchanged. Our contrasting view required an atmosphere which was a dynamic extension of the biosphere itself." End quote. It's not surprising that the Gaia hypothesis was initially controversial and slow to be accepted. By 1974, Lovelock and Margulis were publishing scientific papers on Gaia. However, they also published a paper for non-specialists titled "The Atmosphere, Gaia's Circulatory System" in Stuart Brand's Coevolution Quarterly. New Age connotations and the fact that the theory was championed by many non-scientists didn't help their cause. Another issue was the sheer complexity of the biosphere and its interlocking parts. Scientists had trouble making robust and predictive models of its behavior. But contrary to the scientific community's cool reception of the Gaia hypothesis, NASA was very interested in Lovelock's ideas regarding planetary atmospheres. Gaia theory proposes that bacteria and other organisms not only consume and replenish atmospheric components, like oxygen and methane, but also maintain our biosphere's temperature and habitability through rock weathering and the cycling of carbon, oxygen, sulfur, and other chemicals. The atmosphere is understood as a coupled system with the lithosphere, hydrosphere, and the planet's biota, and these geospheres interact in cycling water, minerals, chemicals, and atmospheric gases. The theory, however, evolved over time and represented a spectrum of ideas. At one end of the spectrum was the uncontroversial premise that living organisms have altered Earth's atmosphere and surface geology. Following from that is the idea that the biosphere and the Earth co-evolve in a way that is self-regulatory due to negative feedback loops. The most extreme form of the theory, containing the idea that the entire biosphere is somehow a living organism, with the teleological implication that the continuation of life is a purpose of coevolution, has been discredited. And Lovelock was always clear about not subscribing to these views. Nor were Lovelock and Margulis the first to consider Earth's biology and its geospheres as intimately coupled. Early proponents of such thinking were the 18th century Scottish geologist James Hutton, the father of modern geology, and the Russian mineralogist Vladimir Vernadsky. Hutton was among the first to theorize how rock cycling impacted our entire planet, referring to the Earth as a superorganism, while Vernadsky theorized in the early 20th century that geologic processes contributed to sustaining the biosphere. Lovelock and Margulis's integrated view supposed that microorganisms not only maintained Earth's habitable atmosphere and climate, but also could alter the environment on a planetary scale. For this and reasons noted above, Gaia hypothesis seemed preposterous to many people. However, as Lovelock explains in The Vanishing Face of Gaia, 2009, quote, "It is too often wrongly assumed that life has simply adapted to the material environment, whatever it was at the time. In reality, life is much more enterprising. When confronted with an unfavorable environment, it can adapt, but if that is not sufficient to achieve stability, it can also change the environment." End quote. Stromatolites in Australia's Shark Bay oh, Jesus, I'm sorry. Can you tell I've been reading for too long? Stromatolites in Australia's Shark Bay indicate, for example, that by 2.4 billion years ago, the progenitors of cyanobacteria developed oxygenic photosynthesis and began to reconfigure the Earth's early atmosphere from largely nitrogen and carbon dioxide to the nitrogen and oxygen-rich composition we breathe today. But any correlation between the emergence of oxygen metabolizing life and global atmospheric composition is complex. Measurable levels of oxygen appeared 300 million to a billion years after the first evidence of oxygenic photosynthesis, which indicates other geologic or hydrologic processes were simultaneously stripping oxygen from the atmosphere. The complexity of how microorganisms and geochemical processes combine to sustain or alter our atmosphere remains at the core of Gaia theory and Earth system science. That's the end of that section. Whew. Sometimes when we get into the chemical nitty-gritty stuff, it's a lot. You swapped bacteria. That's one way to say it. Oh my gosh. That sounds so dangerous in this post-COVID world. I guess we're not post-COVID. It's present COVID, I guess. That's cool though. Alan Shepard. He's the same astronaut who hit golf balls on the moon. That's awesome. That's fun. That's really cool. All right, let me check this. It looks like we have about 4 or 4.5 pages left. Chemistry is hard. It's just so many syllable words. And then they'll do like oxygen and then oxygenic, photosynthesis, photosynthesize, photosynthetic, just all like in the same, It's interesting how Buddhism and many indigenous cultures have spiritual traditions that also emphasize a kind of Gaia theory. Yeah, that is, yeah. Yeah, Oxbowman, that's a good point. I like the, I back in high school or middle school, in a social studies class, we got to do extensive units on different religions and different cultures and how they, all their creation myths and stuff like that. And and like world view stuff. And yeah, Buddhism and some others are very like with the whole interconnection between plants and animals and humans and the world and stuff, and like yeah, it's very interesting. I think English is easier than Chinese. Oh yeah, I can barely speak English. I'm not gonna claim that I can speak any other language. But you know, speaking reading dense science English for 20 something pages, you get a little tired, a little tongue tied is all. Chemistry is so hard. He preferred physics. I didn't like either of them. I did have an earth science class back in when I was going there. My high school required freshman year you were taking an earth system science class, and they changed it, and now you don't have to take it, which I think is kind of a shame because I really enjoyed that. Learned a lot. But yeah, we shall continue. NASA and Earth observation. Quote, "When you cut your teeth on other worlds," Carl Sagan once noted, "you gain a perspective about the fragility of planetary environments and about what other quite different environments are possible." End quote. Sagan points to James Hansen's research of Venus that led to early climate models to predict how greenhouse gases had been trapped in its atmosphere and might similarly impact Earth's climate, as well as Mario Molina and Sherwood Rowland's investigation of chlorine and fluorine molecules in Venus's atmosphere that led to an understanding of the threat of CFCs to Earth's ozone layer. These investigations of Venus revealed that Earth's dynamic biosphere could lose its ability to support life. Lovelock has expressed his concern not so much that our carbon footprint will destroy the Earth, but that warming of Earth's atmosphere could mean the end of our civilization as we know it. Suggesting we make plans for sustainable retreat, Lovelock, at the age of 89, comments, quote, "It's really a question of where will we get our food, water, how will we generate energy?" End quote. This is not a new position for Lovelock. Even from the beginning stages of Gaia theory, Stephen Dick and James Strick comment, quote, "He realized that the gases that living organisms most actively affect, especially carbon dioxide, methane, oxygen, and water vapor, are just those gases that most dramatically shape the climate of a planet." End quote. Quote, "I can only guess the details of the warm spell due," wrote Lovelock in 1988. "Will Boston, London, Venice, and the Netherlands vanish beneath the sea? Will the Sahara extend to cross the equator?" End quote. He's not being facetious. Let me move this a little. There we go. Okay. In The Ice Chronicles, scientist Paul Majewski and science writer Frank White discuss the findings from the Greenland Ice Sheet Project 2's Discuss the findings from the Greenland Ice Sheet Project 2's ice cores drilled in central Greenland in 1990. The cores capture a 100,000-year record of the chemical composition of Earth's atmosphere and a picture of the rate of thinning of Greenland's glaciers. Of the book, Lynn Margilis noted, quote, "The story of how international science obtained this fund of Pleistocene data from the central Greenland ice sheet reads like a novel." End quote. However, this text isn't some action-adventure tale of humans against nature, but a serious assessment of changes in atmospheric composition over long timescales. Captured deep in the Greenland ice are tiny air bubbles that serve as time capsules from thousands of years ago. Scientists can analyze the air in the bubbles to determine the composition of Earth's atmosphere in ages past. Majewski and White assert unequivocally that increases in methane and carbon dioxide produced through industry, agriculture, and mass transport are dramatically warming our planet's atmosphere. They write, quote, "As with CO2, methane is increasing at a rate that has never before been seen. And, as with CO2, the increase correlates strongly with rising temperatures. The result is that we are having a profound impact on the climate system." End quote. Majewski and White noted Majewski and White note that the ice core data indicated that ecosystems on a global scale can be easily and quickly disturbed. I noticed the chat was blowing up a little bit. Oh, you guys are talking about chemistry and physics and stuff. Terms in chemistry and biology are more understandable if you know what the root words. Yeah. Yeah, it's funny because, like, you know, it's all words that I recognize and I understand. But sometimes, like, a lot of the times you're not saying them out loud, you know? You just, you know, you don't usually like read passages like this out loud. You're reading in your head. And so your brain is just like, yes, I know what that means. Keep going. But sometimes your mouth stumbles over them a little bit. Back in the day, a lot of high school students in the U.S. would take Latin. Yeah, we had Latin. I don't know if they still have it, but my high school offered Latin. I didn't take it. I took Spanish instead. All right. Did we have an interruption in our feed? I hope not. All right. Let's continue. Climatologists are concerned that global warming could cause the collapse of the world's ice sheets, which in turn would produce an unprecedented rise in sea level. In 2011, British glaciologist Alan Hubbard reported that an expanse of glacial ice estimated at twice the size of Manhattan was on the brink of breaking free from Greenland. The previous year, a stretch of ice 4 times the size of Manhattan, spanning 112 square miles, broke off the Greenland ice sheet and was adrift at sea in large chunks. Quote, "The fresh water stored in this ice island could keep the Delaware or Hudson rivers flowing for more than 2 years, estimates Andreas Munchow at the University of Delaware. It could also keep all U.S. public tap water flowing for 120 days. Though Munchow emphasizes that ocean scientists, glaciologists, and climatologists cannot yet predict the effects of melting glacial ice, he's nevertheless concerned, and he's not alone. The 2001 Amsterdam Declaration on Global Change reads, quote, "Global change cannot be understood in terms of a simple cause-effect paradigm. Human-driven changes cause multiple effects that cascade through the Earth system in complex ways. These effects interact with each other, and with local and regional scale changes in multidimensional patterns that are difficult to understand and even more difficult to predict. In terms of some key environmental parameters, the Earth system has moved well outside the range of the natural variability exhibited over the last 500,000 years at least. The nature of changes now occurring simultaneously in the Earth system, their magnitudes and rates of change are unprecedented. The Earth is currently operating in a no-analog state." It's no coincidence that's the end. End quote. It's no coincidence that Gaia theory emerged in the late 1960s and early 1970s, at the height of the space age, precisely as space travel and satellite observation began offering consistent and detailed global views of Earth. NASA's Landsat-1, launched in 1972, was the first satellite dedicated solely to Earth observation, particularly of land masses. Nor is it surprising that the original cover of Lovelock's book, Gaia, A New Look at Life on Earth, from 1979, was illustrated with Apollo 17's whole Earth photograph, considered among photo historians as the most reproduced image in history. While Gaia theory forces a planetary perspective, as Lovelock points out, that invaluable perspective was only possible with a serious commitment to space exploration. Quote, "It took the view of the Earth from space," writes Lovelock, "either directly through the eyes of an astronaut or vicariously through visual media, to let us sense a planet on which living things, the air, the oceans, and rocks, all combine in one as Gaia." End quote. And there's a picture here that I have for you guys. There it is. So they were talking about the pictures of, looking back on Earth. And this isn't the super popular one. The super popular was the Apollo 17 one. But this says, Earthrise in the orientation from which the Apollo 8 crew saw it from lunar orbit. In zero gravity, the normal senses of up, down, and the horizon have no particular meaning. Just 24 astronauts have ever experienced the extraordinary sight of their home planet rising over the horizon of another world. So, yeah. No matter how many times one sees it, our planet is just wonderful. It is. It's beautiful. I love pictures like this. It's so cool. It's, yes, definitely cows, make a lot of methane. To save Earth, are we going to sacrifice them all? I don't know. I mean, that's a whole other thing with, you know, the production of dairy and beef cows and stuff, and then they produce methane, and it's a whole... Everything's broken, right? But, you know, we're all trying to do our part, I'm sure. All right. Got about a page and a half left, so we will finish this out. By 1983, NASA had established the Earth System Science Committee, ESSC, to publish recommendations for a concerted science program in global Earth studies and satellite observing programs. NASA's planetary science and recent Earth observing missions have offered scientists their best understanding yet of the complex and interconnected Earth systems that sustain our biosphere. Several missions are specifically focused on understanding and mitigating, if possible, the effects of industrialized human activity. NASA's GOES satellites offer real-time data regarding Earth's weather systems. The Aqua mission measures all aspects of Earth's water cycle in the solid, liquid, and gas states, as well as global water temperatures, vegetation cover, and phytoplankton, which construct their shells from carbon dioxide and deposit that carbon onto the seafloor when they expire. The joint NASA and Argentinian Aquariums mission catalogs the salinity of Earth's oceans, while NASA's Aura mission monitors changes to Earth's ozone layer in collaboration with the German Aerospace Center. NASA supports the GRACE mission. Oh. Sorry, I thought that was a period or a comma and it was period. In collaboration with the German Aerospace Center, NASA supports the GRACE mission, which has observed a large drawdown of fresh water globally from northern Africa to the large agricultural San Joaquin Valley in California. NASA and the French Space Agency together support the Calypso mission to track airborne particles or aerosols to determine their impact on global climate. These are only a handful of the varied and complex missions NASA supports in observing Earth's biological, hydrological, and geochemical systems. What we have learned from missions like these not only helps us to better understand climate change and its impact on life on Earth, but also has prepared us to search for life on moons in the outer solar system and on exoplanets orbiting nearby stars. When telescopic detectors become sensitive enough, astrobiologists will scour the spectra of exoplanets light years away, searching for the biomarkers of oxygen or ozone, as these gases have no other significant source on Earth than its living organisms. In 2006, on the 30th anniversary of the Viking mission, Joel Levine, principal investigator of the proposed Mars-Ares mission to fly a robotic plane over Mars to search for evidence of life, noted that scholars are still researching Viking's nearly 60,000 images, which remain, quote, one of the most productive datasets we have ever obtained, end quote. Venus and Mars, the closest worlds to Earth, retain their allure and mystery. Venus is a near twin of the Earth, our true sister planet. Yet a runaway greenhouse effect has heated it to the point where life isn't possible. It's a salutary reminder of what might happen if we don't get our house in order in terms of carbon emissions. We wince and turn away. Mars, meanwhile, is the lightweight cousin of the Earth. In 2009, scientists at the India Space Research Organization, ISRO, reported having discovered thriving in Earth's stratosphere 3 previously unidentified species of bacteria, despite consistent exposure to ultraviolet radiation that usually kills such organisms. Given that conditions in the Earth's stratosphere closely resemble the atmosphere on Mars, the finding profoundly recalls Vikings' controversial experiments conducted on Martian soil decades ago. If there is biology on Mars, it leads a tenuous existence in hospitable pockets below the surface. Until we definitely discover life, either on Mars or elsewhere, we invest these worlds with our full imagination and project onto them our hopes, fears, and longings, anticipating the time when our isolation ends and we find companionship in the cosmos, if only in a colony of microbes. And that's the end of that chapter. I saw the chat blowing up there. Let me review. What were you guys talking about? Kill a cow, save a planet. Oh my gosh. Send cows to Mars. Cows politely disagree. Don't mess up Mars too. Oh my gosh. Somebody call NASA or Elon Musk. We're gonna need a bigger Falcon Heavy. Cows would probably prefer the moon. Oh, very funny. Very funny. You guys just gotta talk about your cows. That's what you were doing. You were talking about some cows. Yeah. Livestock production does have a lot of really negative consequences for us and for the Earth. And, you know, there are a lot of complicated... it's a complicated problem, obviously, because, you know, food production is something that is needed because we need food to live. But yeah, I honestly don't know a lot about that. There are a lot of very intelligent scientists that know much more than I do. There must be a question in some exam somewhere asking about the amount of energy needed to send an average car to Mars. Of course. We've sent a Tesla to space, and I'm sure that was not a question on a test until it happened. But a cow, definitely. A whale, I feel like I've seen that. Feel like I've seen a whale. I feel like I've seen an elephant. You know, the big ones. What is this? Oh, that's very good. Oh my gosh. This is Single Coded sent this, and it's a little meme, or a little image that says, assume a spherical cow of uniform density, moo, while ignoring the effects of gravity, and he's floating, and then in a vacuum, and he can't breathe. Bastard theoretical physicists, how do you sleep at night? So it's just like, I think it's just making fun of the way that some questions are written, where it's like, assume this thing happens, and this and that, and it's just like wild things that put people or animals in like not great situations, which is pretty funny. Or the whole like you know, if two trains are going at this speed and that speed, what happened, how long will it take them to collide or something, or what, you know, velocity will they be at when they collide? And it's like, well, that sucks if for the people that are on the train. Escape velocity question. Yeah, as a meat lover, you can't think of transferring to artificial meat. Yeah, me and my partner have been working on it, and it's different, but you know, there's some nice benefits to it. We've just been trying to eat less meat in general, which I think is a good way to start off if you wanna make a little bit of an impact in your daily life. We don't usually go for artificial meat though. We just do more like vegetables kind of stuff. Veggie based things or you know, pastas, stuff like that. The mass of the average dairy cow is that many grams. Oh my gosh. I am not going to do that math. I will let you guys try to figure that one out. Yeah, Oxbowman said, ironically, we might discover life on exoplanets through the pollution caused by their civilizations, which is totally possible because, yeah, there are some things that, like, you know, I imagine would not be evident, or like would not be seen on a planet unless it was a planet that was like kind of polluting their atmosphere like we're doing, which is crazy. But yeah, I think that's pretty much it. I hope you guys all enjoyed hanging out, talking about cows and things and Mars. That's the end of this chapter. Next chapter is all about Mer, MER, the... Oh, thank you for the anonymous cheer. Anonymous cheer. Thank you so much. Mer, the little rovers that could, is what the next chapter is about. So we'll do that next week. And just as quick review of what else we're doing this week, let's see. Tomorrow, I believe, we have Professor Impey's Q&A stream on the YouTube channel. So that will be listed already. So you guys can go and find the time for that. I'm not quite sure what time. I think it might be like 1 or 2 maybe, or it's in the morning. I'm not quite sure. And then on Wednesday, we are going to do a special astronomy news that is all about the Perseverance rover. So if you enjoyed talking about Mars today, please come back on Wednesday at 11 Pacific Standard Time, or it's on the schedule in your time. It's going to be a really good time. We're going to talk all about Perseverance because it's landing on Thursday and we're really excited. So come join us for that. And then on Friday, we have our amateur astronomy with Matthew. So yeah, that's the schedule for this week. The Perseverance, we're not going to do a watch stream, I don't think. It's a good idea, though. When is Perseverance actually landing? Let's see. 3 o'clock, 3:45 Eastern time. Okay. I guess we could. I'll talk to Michael about it. We'll see. Because he has I wouldn't want to do it alone. Because I like doing book stream alone because there is something for me to do. If people aren't feeling, if we don't find something to like chit chat about, then I'm still reading. But I'll see if Michael has class or not, and we'll see if we can do that. But we'll definitely be here on Wednesday talking about it. So join us then. Yeah. Less beef in our diet is more methane, which kills the earth. Oh my gosh. All right. Well, thank you guys all for being here. Thank you for hanging out. Thank you again for the subscription, Lynn Jersey and Anonymous Cheer, for those bits. Also, one more reminder, if you guys want to be part of that asking questions for Chris in that special stream on March 2nd, you need to be subscribed for that, so feel free to do that if you want to. It's only like a month at a time, so if you guys want to just subscribe for that, for like one of those or something, and then stop, that's totally fine too. But yeah, I will remind him he will lose the plant as well. All right, thank you guys for hanging out, and I will see you all on Wednesday. Bye.